Okay, here we go with lesson number 18. It is called Working with Radicals and Products of Polynomials. This is the last part of our entire section of radicals or exponential things. So very soon, some of you will be quite happy to have a welcome break from all of the radicals and exponents we've been dealing with the last few weeks. In this lesson, we simplify radicals that come from the quadratic formula, and we multiply polynomials using the box method. Number one, we will soon cover something called the quadratic formula. Raise your hand if you think you could say that out loud without reading it. Quadratic formula, you've all seen it before. Who's got it memorized? If you're shaking your hand like a so-so, that means you don't have it memorized. Yep, we got a few people, right? We're going to see this formula soon enough. I trust you have seen it in some other math class. It's okay if you have no idea what it represents. We will explain it. But this is a good time for us to be able to simplify answers that are going to come from this crazy formula in our class soon. So things that come out of that crazy formula often look like down here, this example, -16 plus or minus the square root of 128 over 8. That kind of thing is going to come out of this formula in a few classes. So for right now, I don't need us to know the formula or understand what it means, but I do need us to be able to simplify things that are like that, because that's going to be a part of bigger problems very soon. So here's the technique. It's all written out here, so we're just going to do some pointing. 128, is that a perfect square? No. So we are looking for numbers that go into 128 that are perfect squares. You can try 4, 9, 16, 25, right? You run through the list. You find the biggest perfect square you can. It turns out 64 is that biggest perfect square. And 64 goes into 128 2 times. So we buy 128 is still 128. Yes? 64 times 2. And then we recognize that we can take this guy and split it into two radicals. I actually didn't write that step out, but it's something we've seen. And the square root of 64 is going to come outside and become 8, right? Square root of 64 becomes 8, so that is there. Notice that the square root of 2 is still inside, right? So all of that is old. The new part is this next step. The new part is going from this single fraction to the two fractions that are over here. So I'm going to write down something up on the board. Let's do this. 3/5 plus 11/5. What does that equal to? 14/5. What if somebody really didn't understand how you got 14/5? What would you explain to them for where the 14 came from? It's the 3 plus the 11, right? And it's something that, like, you would never write that step out, but it's in your head, right? I mean, you understand that's what you're doing. Okay, that is a very common direction for you to go. Take two fractions that have the same denominator, add them together, and make a single fraction. But if this equation is true from left to right, then gosh, it's sure going to be true going from right to left. If you happen to have a single fraction with a plus sign in the middle on top, you could split it into two fractions, yes? Why would you ever do that? It's going the wrong way, right? Like you have a lot of experience going left to right here. But we could go right to left. It is valid, yes? So what we're saying here is that if you have a fraction with two guys on the top separated by a plus sign, you can split it into two fractions. And notice that the 5, the single 5, ended up getting split and became two copies of the 5. That's exactly what we're doing here. We have a single fraction. What's the denominator? 8. We could think of it as having come from two fractions where the denominators were both 8. And that's exactly what we've written here. So you had the first guy, that -16. It is divided, whoops, I'm on the wrong one. So this guy right here, -16 over 8 is there. And then the plus or minus gets copied in between. And then the 8√2 over 8 gets copied here. All right? Again, something you don't have maybe any experience going that direction, but you should believe that it's true from the direction you've done all your life. And now that I'm split into two fractions, I can reduce. -16 over 8 becomes -2. 8 radical 2 over 8. I can cancel there. The 8 and the 8 cancel, and I'm just left with the 1 radical 2, which is here. One thing that is maybe tempting but is not okay is to reduce the 2 and the 8. Why can I not make that a 1 and a 4? It's not a 2. It's the square root of 2. And if something is in the square root and something is out of the square root, they don't play together. They're just not under the same roof. So, got to be careful that you're only reducing things that go together In this case, the 8s are both outside, so they play well together. So we get -2 plus or minus √2. Questions on that? So this is how we do it. That's all we're going to say about this guy. You'll get practice in the activity in just a few minutes. But very tempting to do the following, which is wrong. -16 over 8. I can reduce that. -16 becomes -2. 8 becomes 1, right? And if you do that, then you will have, like, so you might be tempted to say, okay, so that's it. -2 plus or minus √128 over 1. Looks reasonable. The fact is that 8 in the bottom was underneath both of the pieces. And if you just cancel it here, you lose the fact that the 8 was underneath the 128 as well. So this is why I always think it's a good idea to split before you reduce, and you'll have this temptation in a lot of problems to reduce. Before you reduce, split. That 8 is going to affect both pieces. Okay, so that's all we're going to say about radicals for a while. Let's come down to number 2. Let's change gears and talk about multiplying polynomials. We'll learn the box method, since the box method is very general and will help us with an important upcoming topic called factoring. So part A says we're going to multiply these two things together. They're both called polynomials. 4x cubed y to the 5th is going to get multiplied by this entire thing, -3xy squared, blah, blah, blah. So I'm going to write the problem out just here in the blank. 4x cubed y to the 5th times, you don't need to copy this, but this is what we're after. What word is the word that applies here? It is multiply. Could somebody give me a fancier word? What is it? It's a word I have been misusing for the last few classes. This is the distributive property. This is actually the distributive property, right? So you guys know that you're going to take this guy and you're going to multiply it by each of the 3 terms in the parentheses. And it's something that you can do without any assistance from me. You have done this before. But I want us to do it in a different way. We're going to get the same answer. We're going to get the answer that you already know how to get, I think. But we're going to use this thing called the box. Now, the box is not going to be required on any quest or test. And in fact, it seems a little bit silly to use the box on problems that are easier to do elsewhere. I'm not even saying the box is easier. But what I am saying is that in a couple of classes, actually I think next class, the box method is going to help us with problems that you might not currently know how to solve. And so I'm trying to build a good foundation with problems that you already know how to solve by using this box so that we'll be in a good position to solve problems that you might not be able to do right now, again, using the box. So just bear with me, even though it's probably easier for you to just do this familiar technique of distributing. Okay, so here's how we set it up with a box. This guy on the front is going to go on the left-hand side, 4x cubed y to the 5th. How many terms are in the parentheses? 3 terms. They each go above one of these little rectangles here. -3xy squared minus 7x cubed plus 2x squared y. This is why the box has 1 row and 3 columns in it. It's because there was 1 term in the front, 3 terms in the parentheses. And what we're envisioning is that for this, let's just focus on this rectangle right here. I am envisioning that that rectangle is labeled with its length and its width. I'm imagining the width of this rectangle, which is here to here. I'm imagining that the width is represented by 4x cubed y to the 5th. And I'm imagining the length is -3xy squared. And what we're going to fill in inside of that rectangle is its area. In English, how do we find the area of a rectangle? Length times width. So all we're going to do is multiply those 2 things we just said that are outside. So multiplying the 4x cubed y to the 5th by the -3xy squared, 4x cubed y to the 5th times -3xy squared. Some of you might not need to write it. It's okay if you don't have to write it, but if you're not sure, write it. So we're just going to shuffle these things around in our minds. The numbers multiplying give 12. Okay, let's hear from someone else. What about these x's? X to the 4. And then somebody else. Y to the 7, we buy that. Right, we're just adding these powers. So that's what goes in the first box. Any questions on that? please fill in the other two boxes. We're looking for areas of those boxes. I've drawn some arrows to help you know which things we're multiplying. Totally different from FOIL. Yes. FOIL applies to problems that look like this, but I'm not a fan, so I'll show you how to do it with the box. Can anybody check my answers? In the middle, I have a negative 28 x to the 6 y to the 5th. And then at the end, 8 x to the 5th y to the 6th. That's it. And so our answer for this multiplication that I insisted we not do with the distributive property is just whatever's in the box. Negative 12x to the 4th y to the 7th minus 28, et cetera, et cetera. It's just written out right here. Okay, so we're just reading it right from the areas of the rectangles. I want you guys to buy that what we just did is equivalent to the distributive property. What we did was took 4x cubed y to the 5th and multiplied it by each of the three terms, right? And we called it areas, but it's just the distributive property, right? That guy on the outside times each of the three terms. Nothing new. Just a visual way to think about it. Okay, number 3. Yeah, the only way we could simplify is if we had, yeah, we would need the powers on an x to match and the powers on a y to match. And we can't. X to the 4th doesn't match x to the 6th, doesn't match x to the 5th. It's a good thing to look for, though. Okay, number 3. We're going to multiply 3x minus 4 by negative 2x plus 5. Matt had mentioned FOIL. This is a problem that some of you have solved in a previous math class with FOIL. Here's what we're going to do. 3x minus 4, I'm going to put the 3x here. I'm going to put the negative 4 there. Go ahead and put those in front of the rows. And across the top, we're putting the negative 2x and then the plus 5. And so, for example, if I put a box around this rectangle right here, what is our expression for the width or the height of this box? It's labeled as what in this diagram? Is the 3x. The height itself is just the 3x. What's the length of this rectangle? Is the 5. And so when we fill in the area of this green thing, we are multiplying 3x by 5. So it gets really cluttered if you have to write these arrows every time. So I'll just write the 1, but that's the multiplication we're doing there. So inside here we put, what, 15x? Please multiply and fill in the areas of the other 3 rectangles. Anybody put negative 6x in the top left? Should some of you put negative 6x? Don't be shy. Some of you put negative 6x. What should it be? It should be x squared, right? So we just got to be really careful that we are keeping track of all of the x's. Bottom left is 8x. Okay, it's totally fine to put 8x. I am going to try to be in good habits here and put a symbol in front of every one of these things. What's the symbol in front of the 8x? Is a positive sign, right? It's okay if you don't put it. 15x is also positive. Just think it's going to help a little bit. And then in the bottom right is negative 20. And so all we're going to do is rewrite that stuff that's in each of those boxes. So I'll start in the top left. It says negative 6x squared. And then going across the top, I see it not just a 15x, but a plus 15x. And so that's why I go out of my way to put pluses, even though you don't have to. You do when it comes to writing down your final answer. That is a plus 15x, bottom row, plus 8x. subtract 20. Okay, Jack had asked about combining terms on the previous one. It was a great question. We couldn't go any farther. Which terms combine here? The 15x and the 8x gives 23x. You guys do not sound good. It's like a sick ward in this room. X minus 4, negative 2x plus 5. This is the multiplication we just did. Raise your hand if you have seen FOIL in a math class before. FOIL stands for first, outer, inner, last. So if you do the first times the first, what do you get? Negative 6x squared, that's this guy. If we do the outers, it's positive 15x, yes? That's this guy. Inners? Positive or negative 8x? Positive 8x, that's this guy is the inners, and then the last is negative 20, which is this. So the box is doing FOIL. It's nothing new. It's not that FOIL is bad, but FOIL is kind of bad actually, because FOIL is only appropriate when you have a two-termed thing times another two-termed thing. These are called binomials. A binomial times a binomial. Because if I instead gave you something more complicated, like in this example here, how many terms in the first parentheses? 3, second parentheses, 4. Good luck with FOIL. FOIL is only good for a two thing times another two thing. And so how about instead of like spending so much time on this one limited application called FOIL, we just learn something that is appropriate to any polynomial times any polynomial, like the box method. It's just the distributive property. In this one, it's the distributive property on steroids, like negative a has to multiply by 4 things. And then that minus b has to multiply by 4 things. I don't really have room. I'll put it in another color, I guess. Then the c multiplies by 4 things. It's just the distributive property. But FOIL is just such a limited use of the distributive property that I actually wish we didn't cover it at all. If you choose to do FOIL in this room, no problem. But recognize that you're going to see problems that are not FOILable. Speaking of this massive distributive property that's highlighted, if we wanted to do the box, how many rows would it have? 3 rows. Each guy in the first parentheses is going outside of a row. How many columns would it have? 4. So you'd have a 3 by 4, 12 mini rectangles inside of there. Just do them one at a time. Add them all up. Some terms will combine. Will any terms combine? Nope, no terms will combine. You'll just have 12 things in your answer. That's it. Questions on the box? Okay, so one more time now that we've got a little experience with the box here. The box is not a mandatory part of this course or any quest or any test. But if you'll trust me, it's going someplace good that we might not have another tool for at this moment. So I'd encourage you to use the box, even though you might be able to solve these problems without. Okay, activities on the next page. We have 20 minutes. Let's see how far we can get.